In this video, I'm going to show you some of the properties of triangles and also how to classify triangles according to their properties. You probably already know that a triangle has 3 sides and 3 angles. If you look at its name, triangle, this prefix tri literally means 3. You're probably also aware that triangles can be drawn in many different ways. For example, we can have triangles that have all 3 sides the same length, like F and G. We can have triangles that have 2 sides the same length, like C, D, and A. And then we can also have triangles where no sides are the same length, like B, E, and H. But there are some restrictions to the side lengths that we can have for triangles. So let's look at that more closely. So what I've done right here is I've taken a ruler and I've drawn several different lines of varying lengths. Now this is not to scale, but you can see that it does match up on this ruler, that I have a 5 centimeter line, a 4 centimeter line, a 3, a 2, and a 1. So if I move the ruler out of the way here, I'm going to try to make some triangles from these different lengths of lines to see if I can make triangles from just any lengths that I want. So I'm going to start with the 1 centimeter, 2 centimeter, and 5 centimeter line, and I'm going to zoom in here to make it a little bit easier to see. And now I'm going to try to make a triangle. So I'm going to take one of these sides and I'll go ahead and put it over here on this 5 centimeter line. And I'll take the 1 centimeter side and move it over here. And you can see that no matter how I turn this, no matter how I rotate these sides, they're never going to be able to intersect with each other because they're not long enough. So if I take both of these sides off, you can see why this is never going to work. If I go back and line these up next to each other horizontally, you can see that they're not long enough to be able to reach the entire length of that 5 centimeter line. We had a 2 centimeter length and we had a 1 centimeter length, and 2 plus 1 is only 3 centimeters. So we don't have a long enough length to be able to connect all 3 sides together. And I can show you that this is always true by zooming out here and getting one of my other side lengths. And this time I'm going to take the 3 centimeter side right here. And let me zoom back in so we can actually see this. And I'm going to get rid of this 2 centimeter one because this time I want to use the 3 centimeter and the 1 centimeter. And if we look at it, you can see that it shouldn't be long enough to make a triangle, but let's check that out to make sure that that's true. So if I take this side and let's say I angle this as sharp an angle as I possibly can. It's a little bit hard for me to do here, but about like that. Let me move that over so it actually intersects. And then I do the same thing on this side, as sharp an angle as I possibly can. And again, that's about as good as I can do on here. You can see that that's never going to form a closed figure. So again, if we have 2 sides that do not add up to at least the 3rd side, we're not going to get a triangle. In this case, we had 3 plus 1, which is 4. That's not long enough to meet the 5 centimeter bottom side of the triangle. So let's try if we have a 3 and a 2 side length. And I've already got those pieces right here. So here's my 3 centimeter, and here's my 2. Now these two combine to equal 5, so let's see if we can make a triangle. I'm going to move this down a little bit, and let's see if we can make a triangle. Again, I'm going to do a really acute angle here, and the same thing with this one, a really acute angle, and move it over as best as I can. And you can see that it still appears that my triangle is not closed. And the reason for that is that these 2 side lengths, the 3 and the 2, they match up exactly with the bottom side length of a 5 centimeter, but they only match up when they're in a horizontal position. And right now, to make this triangle, I don't have them in a horizontal position. I have them angled up. So the only way I can get them to intersect at a 3rd vertex is to make them be completely flat. And the problem that I have then is that I'm no longer making a triangle. What I'm doing is I'm making another straight line. So let's now see if we can be successful at making a triangle. I'm going to zoom out again, separate these pieces, and then I'm going to get the 4 centimeter side length. So let's move it over here with our other pieces, and then I'll zoom back in. So I found out that side lengths of 1 plus 2 will not work. I also tried 3 plus 2, that also will not work. So let's try something that is greater than the 5 centimeter bottom side of our triangle. Let's try a 4 and a 2. So let me move my extra pieces out of the way. Here's my 4 and here's my 2. And you can see that that's clearly greater than the 5 centimeter bottom side of the triangle. So let's try now arranging these. And I'm not sure what angle to use, but I'll just go ahead and experiment here. And it looks like I'm clearly going to have enough length to make a triangle. I just have to figure out exactly what angles I need to get everything to match up perfectly. But it looks like, there we go, I've got my triangle made. So what this has shown is that when we are making a triangle, any two sides of the triangle, their lengths must be combined, must be greater than whatever your third side length is. Otherwise, you'll only be able to make an open figure or a straight line. The next property of a triangle that I want to look at is its angles. And more specifically, we're going to look at the interior angles of a triangle. Those are the inside angles. I'm going to trace over each of the angles in our triangle here, and then I'm actually going to shade in the angles with an arc right here and then completely shade it in. Because right now, all of these angles are in the triangle, and it's really hard for us to see any relationships among them. But if I trace over them and then pull them out of the triangle, we might be able to see some sort of relationship. So my last one, I'm going to make green here. And I'll do the same thing. I can draw an arc and then shade in that arc so that we can see the angle. So now that I have my 3 angles from the triangle traced, I'm going to pull them out of the triangle. And I'm going to move my triangle out of the way. And I'm going to arrange all of these angles onto a straight line here. And my straight line, I'm going to have a vertex right in the middle of the straight line. Let's put it right about there. So now I'm going to take each of my angles and I can resize them if I want, but I'm just going to move them and line them up where their vertex is on my new vertex. And again, it doesn't matter if I resize these, the angle size is still the same. Pretty close. And then this one here, I'm going to have to rotate a little bit. And you can probably see already that when I line these up on this straight line, we form a straight angle. So what we have right here is our combined angles from that triangle formed a straight angle, which has an angle measure of 180 degrees. So the question is, does that work for every triangle? So let's test it. Now obviously I can't try every triangle in existence, but I can try to look for a pattern. So I've gone back to our original picture of triangles and I have shaded in the angles of a few different triangles. And let's now line them all up on a straight line or about a common vertex. And let's see if the sum of the angles in a triangle really does equal 180 degrees. So I'm going to start with triangle F. I'm going to pull the angles out and then line them up on my vertex here. I can rescale these angles and that won't change the size of them. And we can attempt to see if we have a sum of 180 degrees, and it looks like that we do. So triangle F, the sum of the interior angles is 180 degrees. So let's now look at our other 2 triangles. And I'm going to go ahead and move these angles out. And then let's zoom in. And I can rescale these as I put them on the common vertex, and it won't change the size of the angles. I'm going to rotate this around, try to line up the sides with each other as well. And you can see that we have a 180 degree arc. So the sum of our angles is 180 degrees. So let's now look at our last triangle. And I'll pull out all of the angles. And I'll now try to line up the angles on the common vertex as best as I can. Let me do the blue one next. I'm going to try to line up the sides of the angles as well as the vertices. It's not going to be perfect, but it's pretty close. Let's resize this red one. There we go. And you can see that we are again forming a 180 degree arc here. So the sum of the angles in our triangle is 180 degrees. Now I encourage you to try this on your own and draw any triangle that you want, and you can cut out all of the angles and line them up just like I did on here to see if you form a straight line, or you can just measure each of the angles and add them all up and see how close you get to 180 degrees. In the last segment of this video, I'm going to show you how we can classify triangles. And in this picture of a whole bunch of triangles, you can see that we have triangles that have different lengths of sides, and we have triangles that have different measures of angles. So those are actually the two ways that we can sort triangles. We can sort them according to the property of their sides and according to the property of their angles. So let's look at what those names are. And you can kind of think of these like a first name and a last name. We can give every triangle a name based on its sides and a name based on its angles. We have some triangles like triangle F and triangle G that have all three of their sides equal in length. And those little markings just indicate that those sides are equal in length. We call these triangles equilateral triangles. And the word equilateral literally means equal sides. So all three sides are congruent. We have some other triangles like triangle A, C, and D that only have two sides that are congruent. Those triangles are called isosceles. Sometimes it can be difficult to see that those two sides, that they have two sides that are congruent, especially if the triangle is rotated in a way that those sides are just difficult to match up in your mind. So sometimes you'll want to pull out a ruler and actually measure to make sure that the two sides are congruent or no sides are congruent. Because some triangles, like triangle B, E, and H, have no sides that are congruent, and I can mark these like this. These markings indicate that all three sides are different lengths. They are called scalene. And I'm going to put no sides congruent. So we can classify every triangle as either equilateral, isosceles, and scalene based solely on the property of the length of its sides. Now for a triangle's other name, we can classify it based on its angles. And of course, all triangles have three angles in them, but we can look at those angles and look at the kinds of angles that they have. If a triangle has only acute angles, so for example, like triangle C here, and triangle F, and triangle B, and triangle G, they have only acute angles, we call it an acute triangle. And it must have all angles acute. If a triangle has a right angle in it, like triangle D, it's called a right triangle. Now, if you think about it for a second, it's impossible for a triangle to have two right angles because a right angle measures 90 degrees. And we know that the sum of the interior angles in a triangle is 180. So if we had two right angles, that would already be 90 plus 90 is 180. The third angle would have to be 0, which would be a straight line. The third type of triangle according to its angles is a triangle that has an obtuse angle in it. So there's an obtuse angle, and it's hard to see on this one, but it has an obtuse angle right here on triangle E, and triangle A has an obtuse angle right there. We call those obtuse triangles. And just like a right triangle, it is impossible for a triangle to have multiple obtuse angles because an obtuse angle is greater than 90 degrees, and you can't have two angles that are greater than 90 degrees and still have a sum of 180. Now, I do want to warn you to be careful that when you're naming triangles according to their angles, it's very easy to look at a triangle and see that it has an acute angle and automatically think that it's an acute triangle. Keep in mind that all triangles have at least one acute angle. For it to be an acute triangle, it must have all three of its angles be acute. For it to be a right triangle, it just needs to have a right angle. And for it to be an obtuse triangle, it just needs to have an obtuse angle. Lastly, to classify each of these triangles, triangle A is isosceles because it has two congruent sides, and it is obtuse because it has an obtuse angle. Triangle B is scalene because no sides are congruent, and it is acute because it has all three angles acute. Triangle C is isosceles and acute. Triangle D is isosceles and right. Triangle E is scalene and obtuse. Triangle F is equilateral and acute, and the same thing is with triangle G. It is equilateral and acute. And triangle H is scalene and obtuse.